part 2 of Module 16. So when we left off, we were talking about selective attention, which is up here at the top. And that was the focusing of conscious awareness on a particular stimulus. But in this next piece, we're going to talk about inattentional blindness, which is failing to see visible objects when our attention is directed elsewhere. So grab this definition, then we'll try a quick experiment. Okay, what you're going to be asked to do is in this next video, count. So be ready to count. Okay, so some of you probably have seen this before, but we're going to try it anyway. So count how many times the players wearing white pass the basketball. You'll have to watch carefully. This will take 1 minute.
Count how many times the players wearing white pass the basketball. How many?
So ask yourself how many passes you got and be honest. They're about to tell you how many.
How many passes did you count? The correct answer is 15 passes. But did you see the gorilla? This video is from research.
So on Google Classroom, I'll have some other inattentional blindness examples there for you that you can try it out. Now that you already know that there's something going on in the video, it's fairly easy to be seeing that something else is going on. But it is pretty hard to get the number of passes right if you're trying to focus in the two directions. The next little piece we're going to talk about is something called change blindness. This is the way like magicians do their work. Change blindness is failing to notice changes in the environment. I have another quick video clip that will help show you that a lot of people, if they don't know what to expect, actually fall for or experience change blindness. So by selectively riveting our attention on one hand's kind of dramatic act, we fail to notice changes that are made with the other hand with regards to like magic, for example. In laboratory experiments, viewers didn't notice that after a brief visual interruption, a big Coke bottle had disappeared, a railing had risen, or a clothing color had changed. Focused on giving directions to construction workers, 2 out of 3 people also failed to notice when he replaced another worker in a staged kind of interruption. And we're going to see that in just a moment. I will say that in class, we've experimented with this in a number of ways by having like, you know, your own friends, your partners go out of the room and change, like flip clothing around. And oftentimes you can't even identify what's changed in the partner sitting right across from you that you talked to during the class period. So let's see another change blindness experiment.
Most of us think we're pretty observant, but with a bit of mind control, I wanted to see if I could make these people take even the most obvious things for granted.
Anyway, you gotta get to Trinity Church from here. You see that church down there?
Yep, straight through there.
And then you're gonna keep going down.
That's right.
Sorry. You see that church is down there?
Yeah.
You stay on that, which is at Broadway. And then you walk down 2 or 3 blocks. Trinity Church is on the right hand side. You're walking in that direction.
Excuse me, you know where Trinity Church is, do you? 19 Wharf in Broadway. Okay. Well, we're down here somewhere, aren't we? Yeah. See, Avenue J. Oops, sorry. Sorry. Yeah. Side there. Avenue Church. Side there. You keep going that way, you went all the way to the That seemed almost too easy, so later on I see how far I can take it.
So
Excuse me, do you know where Trinity Church is? Okay. Last time I switched with someone who looked a little bit like me, but where's the fun in that? Okay, thank you.
You know who best direct you? The other side. See where the lady's standing?
Sure.
That's the pool. No, the lady in the break.
The other side.
Yeah, the other side of the
But you
pool.
say you don't know where it is.
Exactly what street? No, but it's in that direction.
Okay.
Yeah, okay?
Excuse me. Do you know where Trinity Church is? Yeah, fine. Come on. You want to walk now? I'm going to catch some other people. Sorry, guys. Okay, listen. Once you go on Broadway, yes. Remember the numbers are going. Once you hit the Broadway, you're going down. Yes. Walk up straight that way and just walk straight down. You're going to see it, right? It's really brown. That's brilliant. Thanks for your help. All right, but don't worry about it. Excuse me. You know where Trinity Church is? Ah, right. Where are we on here? We sort of there.
Right here.
Thank you.
Go on. We are Brooklyn Bridge. You want to cross over there? Go down Broadway. Okay. Thank you.
Excuse me, mate. Do you know this area? Do you know the area? Do you know Piccadilly Circus? So through there? Yep, through there. Let's just go. Sorry, go on for me. Where? Sorry. Oh, thank you very much. Oh, careful of the car. Cheers, mate. Thank you. Excuse me, are you familiar with this area? No. No? Okay, all right. Piccadilly Circus?
Piccadilly Circus. Coming
Yeah.
out here. Piccadilly Circus is right
Sorry.
here.
Oh, sorry. Sorry, which?
I just saw it right here.
Oh, okay, so is that straight over?
Definitely not that way. Piccadilly Circus, I know it's that direction.
Oh, that way. Oh, okay, thank you. Do you know this area at all? Going to get to St Paul's from here. I'm not even quite sure where we are. Sorry, just trying to work out where I'm going.
We are here.
Right, okay.
Yeah, I think it's sort of stairs in.
I'm sure that wouldn't have worked quite as well if I was a very famous pop star. Well, it took me over 2 hours to find Francesca's keys, which was disappointing, but I did go to Venice for free, and I didn't fall into the canal on the way home like a twat. Sorry, I know how to get the St. Paul's from there. Oh, okay. Is it going? Do you know where we are here?
Yeah, that right there is open.
So obviously, our visual kind of recognition of what happens around us can be manipulated. Next, we're going to talk about transduction. So there are 3 steps that are basic to all of our sensory systems. We receive sensory stimulation, transform that stimulation into some sort of neural impulse, and then we deliver the neural information. And those are the 3 steps. So for example, vision, which is what you were just experiencing, processes light energy. It receives that sensory stimulation, transforms it into some sort of neural impulses that delivers your neural information, which includes the perception of what you just saw. It's a complicated process. So the process of converting one form of energy, whether it be light energy from your vision processing or sound waves from your hearing processes, the process of converting one form of energy into another that your brain can use is called transduction. We'll do some more work with transduction later. There's your quick definition. Pause if you need more time. How do we see, hear, feel, pain, taste, smell, keep our balance? In each case, we'll consider these 3 steps: receiving, transforming, and delivering the information to the brain. We'll also see what psychophysics has discovered about physical energy that we can detect and its effect on our psychological experiences. First, though, we're going to explore some strengths and weaknesses in our ability to detect and interpret stimuli in the vast sea of energy around us. Last thing we're going to talk about in this module today is thresholds. At this moment, you and I are being struck by X-ray and radio waves, ultraviolet and infrared light, sound waves of very high and very low frequencies, and to all of those we are blind and deaf. Other animals with differing needs detect the world that lies beyond our experience. Migrating birds stay on course, aided by an internal magnetic compass. Bats and dolphins locate prey using sonar, bouncing echoing sounds off of objects. Bees navigate on cloudy days by detecting invisible to us polarized lights. The shades of our own senses are open just a crack, allowing us a restricted awareness of what's this vast sea of energy that is out there. An absolute threshold. To some kinds of stimuli, we are exquisitely sensitive. So standing atop a mountain on an utterly dark and clear night, most of us could see a candle flame atop another mountain 30 miles away. We could feel the wing of a bee falling on our cheek. We could smell a single drop of perfume in a 3-room apartment, some of us anyway. German scientist and philosopher Gustav Fechner studied our awareness of these really faint stimuli and called them our absolute thresholds, which is the minimum stimulus necessary to detect a particular light, sound, pressure, taste, or odor 50% of the time. To test your absolute threshold for sounds, hearing specialists would expose each of your ears to varying sound levels. For each tone, the test would define where half the time you'd be able to detect the sound and half the time you could not. The 50-50 point defines your personal absolute threshold. Detecting a weak stimulus or signal depends not only on the signal strength, such as a hearing test tone, but on our psychological state, our experience, our expectations, our motivation, our alertness. The signal detection theory predicts when we will detect weak signals. Signal detection theorists seek to understand why people respond differently to the same stimuli. For example, have you ever noticed that some teachers are much more likely than others to detect students texting during class, and why the same person's reactions vary as circumstances change? Exhausted parents are going to notice the faintest little whimper of a newborn while failing to notice louder, unimportant noises. Lonely, anxious people at speed dating events also respond with a low threshold and thus tend to be unselective in reaching out to potential dates. The bottom line is when you can be more sensitive and more in tune, and as a result your thresholds can change slightly. Stimuli you cannot detect 50% of the time are subliminal. We'll do this hearing test later, so we would have done it during class, which is what other classes have done. Also, just so you know, your auditory thresholds change with age, so you guys are able to hear higher pitched noises than your grandparents, for example, because your thresholds change as you age. So subliminal sounds are below your absolute threshold. Under certain conditions, you can be affected by stimuli so weak that you don't consciously even notice them. An unnoticed image or word can reach your visual cortex and briefly prime your response to a later question. In a typical experiment, the image or word is quickly flashed and replaced by a masking stimulus that interrupts the brain's processing. Subliminal messages are used all of the time in advertising. In a typical experiment, the image or word is quickly flashed, then replaced by a masking stimulus that interrupts the brain's processing before conscious perception. For example, one experiment subliminally flashed either emotionally positive scenes or negative scenes, an instant before the participant viewed slides of people. and then your perception of the people changed based on that.